we just got to this problem where we want to take the inverse Laplace transform of the right-hand side, but we can't because we don't know how to take the inverse Laplace transform of 26 over s plus 3 times s squared plus 4. And so what I'm going to do is I'm going to move over to this page to kind of do a little bit of algebra that's necessary here, and then we'll come back here to plug it in a second. Just because that'll be easier to follow, I feel like, later on for you. But you can work through this all the way through in your notes. Maybe just do a little indent when we do this part. It's the equivalent of an aside to this section. So we're looking at 6 over s plus 3 plus 26 over s plus 3 times s squared plus 4. And what we'd like to have is that this looks like something over s plus 3 plus something over s squared plus 4. Then we sort of know how to take inverse Laplace transform of things that have s squared plus 4 in the denominator and s plus 3 in the denominator, so it would be okay. And the way that we're going to change something that looks like the product of two terms in the denominator into a sum of two terms that only have one of each in the denominator is going to be with partial fraction decomposition. So we're going to say this term right here that was 26 over s plus 3 times s squared plus 4 is the sum of two fractions where you have a over s plus 3 plus b times s plus c over s squared plus 4. And we're going to have to solve for the values of a, b, and c that make that true. So what that means is that we would need, when we take this sum right here, we would have a times s squared plus 4 plus bs plus c times s plus 3 all over s plus 3 times s squared plus 4. And we want that to be the same as 26 over s plus 3 times s squared plus 4. And so all that means is that a times s squared plus, actually I'm going to do the 24 on the other side. All that means is that 24 should be equal to a times s squared plus 4 plus bs plus c times s plus 3. And we're going to go ahead and just start this algebra problem. So that's a s squared plus a times 4, so I'll do 4a, plus bs squared plus 3bs plus cs plus 3c, just multiplying everything through. So that's going to be equal to s squared times a plus b, combining like terms, plus s times 3b plus c, plus 4a plus 3c on the right-hand side. And on the left, I've got kind of 24 plus s times 0 plus s squared times 0. And real quick, I'm going to highlight where everything came from. So I had my as squared and my bs squared gave me my s squared times a plus b. My 3bs and cs gave me s times 3b plus s times c. And then my 4a and 3c are where my 4a and 3c came from. And then I want both these sides to be equal no matter what value s I have. So what I'm going to have is that these things are equal on similar terms, like this. So I'm going to need that 0 is equal to a plus b, 0 is equal to 3b plus c, and 24 is equal to 4a plus 3c. That's going to give me that, let's see, I think it'll be easier to do b is equal to minus a. So that means that 0 is equal to minus 3a plus c, or c is equal to 3a. That means that 24 is equal to 4a plus 3 times 3a. So that means that 4 plus 9 is 13. So 24 is equal to 13a. So it doesn't look right at all. I just would have figured I picked a number that makes a simplify to something better than that. Oh, okay. Here's what happened. I wrote down 24. It should have been 26. That's my bad. Just I copied down that number right there wrong. Okay, so I've got 26 equals 13a. That's way better. If you're sitting there like taking an exam someday and you get something kind of messy, that would be a similar reason to go back and check your work. So a would be 2, which means c would be 6, and b would be minus 2. And so our 6 over s plus 3 plus 26 over s plus 3 times s squared plus 4 would be equal to 6 over s plus 3 plus a over s plus 3 was 2 over s plus 3 plus bs, so minus 2s plus 6 over s squared plus 4. Or that's going to be 8 over s plus 3. 6 plus 2 is 8. Minus 2s over s squared plus 4 plus 6 over s squared plus 4. And now we've broken up that original sum of fractions into a different sum of fractions, but this one being made up of terms that we know how to take inverse Laplace transforms of. So this is L inverse of 8 over s plus 3 plus, no, it was minus 2s over s squared plus 4 plus 6 over s squared plus 4. And by linearity, that's going to be 8 L inverse of 1 over s plus 3 minus 2 L inverse of s over s squared plus 4 plus 3 L inverse of 2 over s squared plus 4. Linearity gave us that one. And just now when I chose to take 3 times L inverse of 2 over s squared plus 4, the reason for that is because I know that 2 over s squared plus 4 is what my L inverse is going to be, that sort of undoes when I had sine of 2t before. So it was easier to have the 2 inside instead of having a 1 or anything like that. And so this is going to be just looking at our inverse Laplace table. L inverse of 1 over s plus 3 is an exponential type thing when we have a equal to minus 3, then s minus a would be s minus minus 3 or s plus 3. Actually, I'll just write that out. S minus a equals s plus 3, so a is minus 3. And then this is a cosine looking thing for s squared plus k squared equal s squared plus 4, so we must have k equals 2. And same thing right here, we must be looking at k equals 2, but this one for a sine and this one for a cosine based on the top being a s or a number. And so our inverse Laplace transform table would tell us that this is 8e to the minus 3 times t minus 2 cosine of 2t plus 3 sine of 2t. And that's just the solution y of t. Oh, I'm not going to put that box there. It blocks out some of the stuff that we just wrote. I'll make that box better. There we go. That's the solution right there. So it took a very long time to get that answer. It would have been a lot faster to solve this as a linear equation, but future problems we'll need to solve with Laplace transforms because we don't have another method for them.